welcome to our talk. My name is Ioana. I am the tech lead of the security team for Eclipse Foundation. And joining me today is Mattia, committer of Eclipse Kura project and also principal software engineer for Eurotech. The plan for today and for the next 30 to 40-ish minutes of your life is to talk about SBOMs. We've structured this talk into two parts. In the first part, I will be discussing I will be explaining for someone who's not familiar with the concept what an SBOM is. Then we'll be talking about why they are increasingly important in today's software landscape and why is it challenging for projects to start generating them and start using them to improve their security posture. And lastly, I will be talking about an initiative we started at the Eclipse Foundation to lower the entry bar for SBOM adoption and to try to help as many open source projects to start generating them. And in the second part, I will be handing over the mic to Mattia, who will be talking about his project's real world story and journey in SBOM implementation and all the challenges they had to overcome to reach the point where they're at. So these are all the spoilers that I have to give, so I think we can get started. And we can get started with briefly explaining what an SBOM is for some of you who might be unfamiliar with the concept. So here's the reality that we live in. Modern software uses hundreds of third-party components. So a typical application may have 200 to 500 plus dependencies. And most of these are not dependencies that your project team selects. These just get pulled in. So these are never directly seen by someone or managed. They just come along in your project. And this is also place where vulnerabilities often love to hide. So there's a risk. The compromise of one such transitive dependency can lead to the compromise of the entire software that is using it. So it's not just a hypothetical scenario. So you can think about Log4Shell. When one transitive dependency, a logging library, affected thousands of applications overnight, and the issue is that organizations were scrambling to even figure out for days if they were even affected, not to say reaching the mitigation stage. So this is the black box problem that we're trying to solve. So how can we say for sure what is inside your software? So let's take a hypothetical example. You're a maintainer of a task management app. This has various components that you need to pick, like a front-end framework and so on. You choose some tools with a version and a license. But then, as you see, these components pull in their own dependencies, and this thing goes layers deep. So how can you accurately capture everything that's nested and comes along with your software? This is exactly the problem that an SBOM or software bill of materials is trying to solve. So it's an inventory of software components, component metadata, so stuff like version, license, things like this, and most importantly, their hierarchical relationships. So you're able to have an accurate snapshot of everything that's comprised within your project. And if the concept is still hard to grasp. Think of it this way. An SBOM is to your app project the same thing as a recipe is to a meal. In your app, you might have components, transitive dependencies, whereas if you were to make chocolate chip cookies, you'd have ingredients. And also you would have a list of steps on how these ingredients are combined to form intermediary products. This applies to, in the case of SBOMs. So, for example, if a batch of flour is contaminated, you would be able to go back to the recipe and see, did I use flour? And what kind? And the same concept applies to vulnerable dependencies. So I hope that makes it a little bit more clear. And with that, we can move on to why we need them. There are a lot of reasons why we need them. But the one to start with is for software supply chain security. It's a topic that has gained a lot of traction in recent years. So basically to be able to identify vulnerable components in your software project, and also if things go really wrong, they help a lot in the event of incident response for security teams to be able to act fast and mitigate the issue. So when the next log4shell happens, and it probably will, you'll be able to answer all these questions really fast. If you don't have an SBOM, then you will be having to look through a bunch of source code and spend days trying to figure out if you're affected. If you have a SBOM registry, then it's just a query, and that's it. And another driver that I'm going to go through really fast is regulatory pressure. For example, the CRA, which is in force with obligations kicking in September. And all of these are converging towards the same set of ideas, mainly that no release is created with known exploitable vulnerabilities. And in order to be able to say that about a product, you need to know what is inside the product, including transitive dependencies. And this is exactly where an SBOM comes in handy. So far, I hope that I convinced you just a little bit that SBOMs are really important. So if they're so great and they're just basically a lengthy file, you might be wondering why aren't more projects generating them, and why is it this a problem that's worth discussing today? Well, because SBOM generation grows quite complex. As you can see here, this is a list of steps that you need to go through, like an engineer has to go through, to build an automated pipeline that generates an SBOM for every new release of a software product. So fairly complex to begin with. And then if you scale it, then it becomes even more overwhelming, because one project might contain one product, but it also may contain 2 or 10, depending on project specifics. And given these products might differ in terms of platform language, all these workflows to generate the SBOM might need tweaking and customization. So it involves a lot of time. It's not a plug-and-play solution. And also for context, at the Eclipse Foundation, we have around more than 400 projects, so 400 projects, each with a number of products. We can see that the scale really grows the complexity. So to summarize, the challenges that projects face in SBOM adoption, there's a really high knowledge entry bar, especially that maintainers are engineers focusing on feature work and security. Sometimes it's not a topic that can take a great portion of their time. So there are multiple competing standards. You might have heard about SPDX and Cyclone DX. And there's also fast-changing tooling. So for each ecosystem language, there are multiple tools that generate SBOMs, each with its own pros and cons. So it's really hard to digest all that information to select which one is the best for your project. And then there's confusing integrations, integration with CI/CD pipelines. So you already have your release pipelines. Where does an SBOM generation step fit in? And there's limited guidance available on what to do with an SBOM after. So there is regulatory pressure to have them on hand. But there is no on how to use them to also improve the security posture of your. So I described scale with multiple products per project, and also there's maintainer availability and buy-in. As I said, security work rarely makes it on maintainer roadmaps, unfortunately, and it's deprioritized in favor of feature work. So this is the context. We've noticed that at the foundation, and what we try to do is to make committers' lives easier as the security team and try to really lower that entry bar for SBOM generation. And we started this initiative doing project collaborations. So far we've helped over 15 early adopter projects. We supported them with hands-on implementation of SBOM generation and upload pipelines. So now these projects automatically generate SBOMs for all their products and upload them to our Eclipse Foundation SBOM registry. So they have now the ability to quickly assess and mitigate potential dependency risks and vulnerabilities. This is a table with the projects that have been part of our early adopter groups, and the variety in ecosystems is not random. We selected some of the most popular ecosystems at the foundation. And the reason behind that was that we try to experiment as much as possible and gain ourselves a lot of experience from all these hands-on implementation support to then develop plug-and-play GitHub Actions workflow templates. I previously said that it almost always requires customization, but what at least make some templates available that projects can copy and then just quickly adapt to their needs. We also developed some documentation. I especially recommend the how to generate and upload SBOMs for your project guide. It's really short, but it's like the essence of the steps that a project needs to do. And we also did security training for developers. These are also publicly accessible and online on the topic. So in terms of resources, this is where you can find our resource library. In our security handbook, most of the resources are linked to that, and also in the on the YouTube channel for the Eclipse Foundation. So we highly recommend you check that out if you want to get started with it. And lastly, in terms of engineering and infrastructure support, our biggest goal for last year was to have our own SBOM registry, so one place where all projects can upload SBOMs for all of their products, and for all users to go to assess risk for the products that they choose to use. So it's sbom.eclipse.org, and you can log in with your Eclipse Foundation credentials. And we also have upload integrations, again, reusable workflows that you can use to upload your SBOM quickly, so no token management and stuff like that. And in terms of the future, we want to keep helping more projects and enriching our resource library with more and more ecosystems, and also improve our infrastructure. Lastly, I want to make a quick mention that this work is part of an investment by the Sovereign Tech Fund, a program of the Sovereign Tech Agency. We're really grateful for that help to improve the infrastructure and tooling for open source projects to comply with upcoming regulations. So this is all on my side, and now I'll be handing over the mic to Mattia to hear real SBOM adoption journey. So thank you.
Thank you, Ioana. So let's briefly talk what I will cover in this part of the presentation. Firstly, I'll talk about why we decided to adopt SBOMs. Then I'll focus on SBOM generation side of things, how much it took us, what challenges we faced, and so on. Then I'll talk about the infrastructure required to generate the SBOM and perform continuous analysis and for vulnerability monitoring. So why SBOMs for Kura? What motivated us to participate in the early adopter programs? To understand why, I have to explain what our project is all about. What is Eclipse Kura? Eclipse Kura is an open source IoT edge framework. It performs device management, data collection, and processing. It's cloud agnostic and provides multiple connectors for the most popular cloud providers. Essentially, we connect to field devices, things, PLCs, stuff like that, manage them, grab data from them, and shoot the data to the cloud. To achieve this, we also need to perform some device management. For example, we need to configure network interfaces, firewalls, etc. What is ESF? We are using an open core model for our software. ESF is the commercial counterpart of Eclipse Kura and shares 90% of the code base. Additionally, we have an extensive add-on ecosystem that allows us to interface with a multitude of industrial IoT protocols, cloud providers, and so on and so forth. Let's take a quick look at where Kura and ESF are actually used. It will make sense all in a bit, I promise. This first deployment comes from the TSK Group, an EPC company mainly focused on energy projects such as renewable energy plants, energy transition, and electrical infrastructures. They're using Eclipse Kura to monitor photovoltaic plants, thermal solar, etc. They're based in northern Spain. Then we have Emrise. They are a building material manufacturing company. Think concrete, aggregates, asphalts, and so on. They leverage ESF for fleet telematics and lab monitoring. This deployment is based in Canada. Then we have Areti, which is based in Rome. And they have a fleet of more than 5,000 devices running Eclipse Kura for electrical power transmission management and monitoring. Other relevant projects in the transportation sector are the Grand Paris Express and our collaboration with Deutsche Bahn. Additionally, we were recently involved in a project for water infrastructure monitoring and control. As a company, we have much more use cases we can show you, but as you can see, these are the main areas we work in. So, why SBOMs? As you might have noticed, our use cases are Particularly sensitive from the cybersecurity point of view, Eclipse Kura and ESF are commonly used in critical infrastructure, and this implies increased security demands. Some of our deployments contractually require constant monitoring of new vulnerabilities and strict policies for updates. This even without taking into account regulatory compliance and the CRA. In summary, cybersecurity is not optional for us. It is a product requirement, a contractual obligation, and increasingly a regulatory one. SBOM gives us the visibility we need to know exactly what is inside our software, assess exposure quickly when new CVEs emerge, and support certification and compliance efforts. With that out of the way, let's focus on our experience with generating SBOMs for Eclipse Kura. We first started being exposed to SBOMs in EclipseCon 2023 and later in OCX 2024. The Eclipse Foundation was instrumental in making us aware of the ecosystem and its maturity. As you can see, it took us quite a lot of attempts to get SBOMs right. I'll get back to that later, but spoiler alert, our build system put us in a bad place for SBOM generation. The turning point was June 2025, when we attended the Eclipse Foundation cybersecurity training, held by Ioana, by the way, where we were given additional information and tools that allowed us to go further in this exploration. Concurrently, we started heavily refactoring our build system for our next major release. We took the chance to perform a field exploration, and finally, at the end of July 2025, we were able to successfully generate a meaningful SBOM. From there, it took us very little time to fully automate the process and integrate with the Eclipse Foundation infrastructure. We were so happy, in fact, that in December 2025, we decided to adopt SBOMs to adopt the same tools at our company, migrating our old vulnerability monitoring system to an SBOM-based one. You might be asking yourself, why did it take so long? Our build system, mainly. I don't know how many of you are familiar with the OSGI ecosystem, but we use Tycho for our builds and leveraged P2 repositories to store part of our artifacts. This meant that our dependencies used a mechanism that was completely sidestepping Maven, and thus the most commonly used tools for SBOM generation were completely blindsided. Essentially, the CycloneDX Maven plugin was not able to understand our dependencies because they were not being listed as Maven dependencies. In the end, since we already had to overhaul our build system for our major release, we walked the extra mile and refactored it to be more SBOM friendly, essentially bringing in the dependencies into Maven. I won't cover this too much into the details since it's very specific to our project, but the audience still using OSGI and Tycho, I have the following information nuggets. Take a look into Tycho 5, support for SBOM generation, which under its hood leverages Eclipse CBI P2 repo SBOM tool, and above all else, good luck. Okay, so let's talk about some more generic challenges and limitations you might face when working with SBOMs. Let's start from a pretty interesting one. As Ioana said, SBOMs are a list of dependencies used in your project. You need to uniquely identify your dependencies in some way so that they can be referenced by vulnerability databases. The main identifier is the PURL, or the package URLs. I think that some of you might already see the issue. It is fundamentally built on the concept of package. What about languages that don't have a package ecosystem? Kura and ESF wrapped some C++ library for low-level protocol stuff, and we had quite some trouble in finding a way to let the tools correctly pick them up. This is both a representational problem and a tooling problem. From the representation point of view, how can I have a PURL for either only library? And from the tooling point of view, how do I recognize a library when there's no manifest nor package? For now, we only have the following suggestions. If you maintain a C++ project, you might want to adopt and look into a package manager like Conan or VC Package, or you can rely on OS package managers like APT and stuff like that. Some commercial tools claim to be able to scan the code and correctly pick up the C++ library you use, but I don't have experience with those. I feel like this is still kind of an open problem for the SBOM ecosystem. Speaking of tooling, what tools should I use to generate my SBOMs? As Ioana said, there's a lot of choice here. It depends on your language, build system, package manager, There's no end-all be-all solution that I'm aware of. Also keep in mind that some tools only generate SPDX SBOMs. Remember, there's 2 major competing SBOM standards at the moment, but you should always be able to convert one from or to the other with some limitation. Here, I listed some of the tools we use and used at Eurotech. One thing to note about is CDXGen. We tried using CDXGen in the jar scanning mode due to our issues with the build system. I don't recommend it since it essentially works on heuristics to infer package metadata, but it might be the best available solution in some situations. So yeah, one of the challenges is finding the right tool for your project. Let's say we now have an SBOM. How do I check it is correct? There's no good answer to this question. In our case, I manually reviewed 200 dependencies, cross-checking with our notice file. It was not fun. This basically boils down to having a human go through the SBOM and see if it makes sense. Please note, do not try to read the SBOM JSON as is. Use something like dependency track to parse the SBOM and visualize the data. Thank me later. Speaking of dependency track, we should now tackle the infrastructure part of this talk. So the process of generating SBOMs varies slightly depending on the technology stack used, but the approach remains the same. Generate one automatically when the software is built. And once the BOM is produced, the components within can be tracked and continuously analyzed throughout the software lifecycle. Software component analysis tools are specifically designed for this purpose. In other words, generating an SBOM is only one piece of the puzzle. You need tools and processes to continually analyze and monitor them. Fortunately for us, the Eclipse Foundation provides all what we need for this goal. The Foundation hosts, as Ioana said, the Eclipse Foundation SBOM registry in the form of a dependency track instance. Dependency track is a software component analysis platform developed by OWASP. You might have heard about them. In layman's terms, it ingests SBOMs, it periodically queries known vulnerability databases, like the NVD, GitHub advisories, and so on and so forth, and matches the vulnerability found on these databases with the software component listed in the SBOM, using the PURLs we already mentioned. Let's take a quick look at how this works. Really simply, upon pushing, but you can actually change the trigger, the GitHub action is triggered. The GitHub action will then generate the SBOM and upload the JSON on Eclipse Autolog, which then is responsible to uploading the artifacts on dependency track. The reason for Autolog being the middleman is due to permission limitation, but you don't need to worry about that. You just need to know that Autolog is a requirement for being able to upload SBOM on the Eclipse Foundation dependency track instance. At Eurotech, we already had a vulnerability monitoring and management process in place, but it was getting quite old and quite expensive. It was set up long before the SBOM ecosystem reached the maturity we see today. Once we adopted SBOM in our open source project, we realized how big of an improvement it would be and decided to adopt it internally as well. The Eclipse Foundation infrastructure was both a training ground and a blueprint we could adopt internally for our own process. So let's take a look at what it meant us internally. Let's start with the old infrastructure. We relied on a proprietary piece of software responsible for scanning our project for vulnerabilities. The output was a proprietary, again, format which reported each CVE affecting the project dependencies. Then we had Jenkins automation responsible for downloading this report, and with an internally developed tool, we will download additional details from the MVD and open a ticket for each new CVE on a Jira board. Then developers would perform triage on new CVEs on that board. Since the output of the tool was a vulnerability report, we needed to perform the scan at least once per week. For some projects, the scan was performed on a daily basis. To give you a sense of scale, we have more than 100 projects between OSs, Kura, and ESF add-ons, etc., each of them with multiple releases. We had to run this job once per week for every project, for every release. Suffice to say, AWS was quite happy with our build. We then decided to switch to an SBOM-based workflow, which is much more efficient. We simply have a job that runs once per release, not once per week, which uploads the SBOM to our own dependency track instance. Why does it need to run only once per release? The output here is a list of dependencies, not a list of vulnerabilities. Vulnerabilities changes over time as more are found, obviously. The dependencies are set in stone once you release your project. Also, developers now perform triage directly on dependency track, which supports this kind of workflow extremely well. Finally, a couple of words about migrating our infrastructure. As Ioana said, with more than 100 projects to monitor, we felt the overwhelmed scale she mentioned. We are still working on it, but the model provided by the Eclipse Foundation and the know-how we acquired really simplified the process. We really think that this approach should serve as a blueprint for companies like Eurotech starting to adopt SBOMs. This also let us appreciate the work the foundation went through to build its infrastructure and supported the SBOM adopters project. Replicating everything on our end was no joke. So that's everything on my end. If you have any question for both me and Ioana. Okay, we have a question there. Possibly 2 questions, okay.
Got a mic for whoever.
Possibly not a hard one.
Yeah, so thanks for the presentation. Is there any momentum to collaborate in the evolution of dependency track? Because at the moment, as I know it from some tests weeks ago, the dependency track is not able to monitor the European vulnerability database. Is that correct?
Sorry?
The vulnerability database of the European Union.
Also, keep in mind that Dependency Track is an open source project, so everybody can contribute, and I've seen a couple of issues that we faced during the integration that were addressed during the time that it took us to prepare the presentation. For example, the notification. They added recently the filtering of the critical vulnerabilities. So,
Okay, and the next thing about the instance of dependency track of Eclipse Foundation, is this open to non-Eclipse member companies, or is there any business model that we can buy in? Or?
How it works now, so I try to speak loud. How it works right now is that Eclipse Foundation projects can upload, only they can upload SBOMs to the platform, but all users can create an Eclipse Foundation account. Everybody can do that and log into the platform to look through these SBOMs. That's available to everyone. And why we design it this way is to allow users to give them the chance to assess risk for themselves whenever they choose to use a component.
Maybe another question. Thanks a lot for the presentation. So it's like 2 questions. The first question would be, like, I think GitHub is also working on different tools and workflows, and also in the Insights tab. Have you looked at this, and why are you? What are the reasons why are you using like dependency track?
If you want, I can answer this one because I looked into it not too long ago. GitHub does provide SBOMs, but it is quite limiting. It only produces SBOM for the head of the Git, the top branch, and only in SPDX format. So it depends on how you, for us, it wouldn't work us because we have a different branching policy. We need to maintain also all the releases, which can diverge from the dependency point of view from the head branch. So essentially, it wouldn't work for us. It doesn't mean that it wouldn't work for you. So you need to look into that, but it is quite more limiting than having a custom deployment, a custom setup like the one that is provided by the GitHub templates provided by the Eclipse Foundation plus the dependency track.
Okay, thank you. And the second question is, am I right that the SBOM is not included directly inside the repository because it's uploaded? Like I think different Eclipse projects still have this dependency file that's generated with the dash tool, for example, which is also like an SBOM, but more or less for checking the licenses.
I'm not sure I understood correctly the question. So the question is there doing something else? Is there uploading the SBOM somewhere else or only in the registry?
Yeah.
This is actually each Eclipse Foundation project will do those. We give guidelines. We currently have this advice. We do not force anyone to upload their SBOMs to even the SBOM registry provided by the foundation. So what we're trying to do is to support them, but the intent is whichever the information is needed. For the time being, the project, the early project that we've worked with decided to upload to the SBOM registry, and they are also uploading the classifiers to the foundation knows. But it is actually
Thank you.
Thank you. I have a combination of questions and remarks maybe to the previous questions. So just about the European vulnerability database thing. So I've been looking into that as well, and I think one of the problems is that it simply doesn't offer an API yet to query vulnerabilities by Perl, for example. So it's quite useless currently. It's just a database that you can browse in the web, but there is no real REST API or so. Then maybe just, to amend what you said about the quality of SBOMs generated by GitHub dependency insights. It's very poor quality. It has very limited support for only a few technologies, so don't bother with it. And also the quality of the SBOMs being generated is very poor. There's very little metadata in there, and the metadata that's in there is not correct in all cases. Now to the real question. Sorry, short disclaimer. So I'm the maintainer of a tool called OSS Review Toolkit, and I'm also a contributor to the Eclipse S.p.A project, which creates the auth server based on the OSS Review Toolkit. I'm just curious, since it is a complete compliant suite to generate SBOMs, whether that was also part of your evaluation. So the Eclipse project is called Eclipse S.p.A. And it's a server basically similar to, you could say, Dependency Track, but Dependency Track has a few limitations. For example, it's not an SCA platform. It cannot perform software composition analysis by itself. You have to import SBOMs. And in that sense, Eclipse S.p.A is more complete because it will analyze your code base from the outside. It supports Tycho, Python, Java, whatever. It can query vulnerability databases, various ones, all the ones that Dependency Track supports plus more and blah, blah. So I just wanted to know whether you're aware of the project, and if you're not, we should probably talk offline.
I'll answer this one if you don't mind. So, like when we decided to go with Dependency Track, Apoapsis was not yet created at the foundation. It was not an Eclipse Foundation project. So we were aware about ORT, but not about Apoapsis and ORT server. We took the decision to go with Dependency Track because we wanted to promote the SBOM generation at build time. ORT is heavily promoting the SCA capability that it has, and we thought that we would want to promote best practices to projects to generate the SBOM at build time so that we get the most accurate information. I know that ORT is very good at it as well. It generates much better information, much better SBOM than GitHub, as you said. But I would like to complement also this answer by the fact that we are using something in the middle between the project and Dependency Track. Currently it's Autodog. We will replace that with something else. Nothing prevents us from adding one more tool one more registry that would provide us with additional feature that Dependency Track would be not providing today, and that maybe perhaps this would be in the future.
Thank you.